All right, good evening, everybody. Let's go ahead and get the music stopped. Turn off my echo of my sound. All right, guess we're ready to get started here. Okay, so tonight we will be looking. Okay, there we go. Looks like everything's set up. Okay, week 5. Everybody's doing really good in class so far. But we're going to look a little bit more at conditional statements, taking a look at some of the issues that people have been having over the last week. Then we want to go ahead and make a game, the high-low guessing game. First, we'll make it without any loops, which isn't as fun, but at least get the basics done using conditional statements. Then we'll start digging into loops, the while loops, the for loops. And then we'll re-attack the high-low game, but we're going to add some loops. That way it can make it a bit more enjoyable to play. And then finally, if we still have time, we'll look at making a health bar using loops. That's if you want to do a little bit of gaming, or look at how to make a dynamic color, I guess like bar of some sort. Okay. If anybody has any questions while we're going, feel free to ask. Going on, Herb. Feel free to ask. Mahalo. Going on, Herb. Feel free to ask. Yeah. If you have any questions as we're going, feel free to ask. I know all of you can't catch the live stream. A lot of you have jobs and stuff like that too. So catch the recordings. The recordings do have a lot of hints and suggestions that help you with the weekly assignments. I can't give any answers to the weekly assignments, but I can definitely talk about the topics. So I'm here to help you all understand the fundamentals of Python. Okay, without further ado, let's go ahead and jump in, look a little bit conditional statements. We got 19 cells here. I got it more zoomed in this time. I got some feedback from some other people saying that I need to zoom in. So if anybody else has any other comments, share, and I'll try and make them better. Okay, so we looked at the if, elif, and else statements. We also looked at the match and case statements last week. How you format them has a big effect on the readability and the efficiency of the code. So bad design would be if we're using a bunch of if statements to check the same value multiple times. So in this case, we have a single variable, x equals 15, and we're saying if x is greater than 10, print out x is greater than 10. If x is less than 10, print out x is less than 10. If x equals 10, print out x equals 10. Else, print f, and here we have the formatted string that we talked about in previous weeks. And we're saying x equals, so it'll say x equals, it'll say the value of x, and it'll tell us in this case that it isn't a number if the else statement gets called. You always want to have the else, even if you're very confident it won't get called, because you never quite know. What if the user inputs a string? Well, in that case, you'll probably get an error because you can't do value comparisons on a string. Can't say is apple greater than 10. You can't do it, so you actually get a value error. But you always want to have your else statement in there, just in case. All right, let's go ahead and run it and see what we get. In this case, we should expect to get the first statement to run true. X is greater than 10. And it actually ran the else statement as well. And so this will be an issue that you pop up because it doesn't know which if block that else statement pops up. So when looking at a bunch of people's assignments, they went if the value was positive, it print positive. If the value is negative, print negative. Else, print the number 0. And so what would happen is you'd input a value of 4, and it would run the first if, and it would check the second one, and then would go ahead and run the else statement. So it would say, your value is positive. Your value is 0. It is neither positive nor negative, which isn't quite true. So in this case here, it ran the first block, and then it jumped down, and it also ran the else block. Jump down isn't correct. Okay? And the reason you don't want to do this is because it's going to go x equals 15. So it's going to come down the first one and say, is x greater than 10? If that is true, it is still going to run, is x less than 10? Even though we already know the first one is true, therefore the others must be false, it is still going to check each one. pardon me, it's going to check each one, and it's going to continue to use a processor, power or processing cycles as it checks each one. So it's going to check if x is greater than 10, even if that's true. It's going to check, is it less than 10? And again, it's going to check, is it equal to 10, even though we know the first one's true. And it's going to print the else. Well, the else always prints, so it's going to go ahead and print that as well. So x is greater than 10, x equals 15 isn't a number. All right. To fix that, we would have to change it into an if statement. So when you have a series of if statements and you're checking just a single value, use the elif statements, because either it's going to be one item, or it's going to be something else, or something else, and then finally the else statement at the end. Okay, you don't want to be checking every single one as an if statement. It mentions it wastes computer time. So what you want to do instead is you want to use elifs. So if x is greater than 10, it'll print the first one. And then if the first one is true, it will then skip all the rest as if it doesn't exist. All right. If the second item is true, let's say x is 9. Actually, let's go up here. Yeah, we ran it. Okay, so let's say x equals 9. In this case, if x is greater than 10, well, that'll be false. So then it's going to go to the next one. Elif x is less than 10. Well, this one is true, so therefore is going to skip all the rest of the code. And that is efficiency. It won't check. Once it hits a single true statement, this entire block, because it's an if, elif, else block statement, the rest of the block is skipped over. Let's say if it equals 10, then it's going to say, okay, the first one's false. All right, we had to check that bit of memory, processing power. Okay, is it less than 10? We had to check that one. And then we come to the third one, x equals 10. And therefore, it will skip the else block at the end. So the goal is we want to find out the most extreme case. In this case, we're starting from the largest value, checking the lowest value, and then checking the equal value. Or you want to check from the highest value and work your way down, trimming it down to the lowest possible value. Or start at the lowest and trim your way up to the highest possible value. But you want to do it to where, as soon as it hits a true statement, it stops running that block of code and skips to the next section. All right? So some people's code came out a little weird. Those who had those issues should know it, but you do not want to do this. You don't want to do if, else. That's bad code design. You're going to get weird things, such as where it's executing 2 lines of print statements when it's not supposed to. All right. Indentation and formatting. As we talk about every week, readability and efficiency are very important because you're not writing the code for yourself, you're writing it for somebody else. Whether it's an instructor or coworker, if you're working in the business. This includes proper indentation, and you only want to nest conditional statements if you really need to. All right. So a bad example is if you have if condition, do this item. Else, if condition, do this item. Else, if condition, do this item. Else, here. So you can see it's a little bit difficult to read. But if you look at what the core is, it's saying if, elif, else. It's just not properly formatted. So this bit of code here, if we go ahead and put it through an example, would look something like this. So age equals 21. If age is greater than 21, print you can drink. This should be greater than or equal to. Okay, there we go. If age is greater than or equal to 21, and you see we have the colon here, and we have the indentation, so this print belongs to this if statement here. And then we have an else. Everything under the else, so this block here belongs under the else. If age is less than 21, and age is greater than 18, print you can't drink, but you can vote. Else, if age is less than 18, print you can drink, you can vote. So under this else here, all of this code belongs to this else statement here. The indentation shows ownership for each block of code. Or the hierarchy. You can also think of it as a hierarchy. So if age is less than 18, you can't drink or vote. Else, print apparently you don't have an age. Because we're checking everything 21 or greater, We're checking 21 or greater. We're checking everything less than 21. See, and that can actually cause a issue here, because the first true statement to hit true will be the one to execute, and it'll skip all the rest. So we'll go ahead and run it. So age equals 21, and look, you can drink. Let's go ahead and go with 19, and then we'll look at the logic error in a second here. So 19, okay. Expectation is you can't drink, but you can vote. Okay, you can't drink, but you can vote. Good. Okay, let's look at 17. Okay, we would expect age less than 18. We'd expect the 17 to kick off right here. Huh, you can't drink or vote. Where did I get it wrong? Oh yeah, because I said greater than or equal to 18, so it actually is the logic error, this one. But we can simplify this. The issue is that it's not well written, because this is actually just supposed to be an elif. It doesn't need to be split down as a separate if-else block of code. So if we want to take it down, this is the same formatting, or same bit of code, it's just properly formatted this time. So this bit of code here is the same as this bit of code right here, except it is much more readable, and it is properly formatted. Everything is indented for this entire block, so I know that this if, elif, and else are all a single block of code. They're not all staggered, and I know each of these are the block that'll run underneath it. So if we want to look at the same example, it would look something like this. If age is greater than 21, elif age is same, and elif here, and elif here, and if we run it, we're going to get the same thing. You can't drink or vote. Oh, because it still thinks age is 17. So let's go. Age equals 21, and then it should say you can drink. There you go. You can drink. Now, we can actually simplify this even more, because we don't need to check if the age is less than 21. And the reason being, because if you are 21 or older, the first if statement will become true. If you are 20, this statement will automatically be false, but you're still 18 or older. If you're 19, first statement will be false, but you're still 18 or older. And if you're 18, it'll still be false. The first statement will still be false because it's under 21, but it is age equal to 18 or greater. So you could actually comment out this line here. So let's say, let's pick like 19. And we'll run it. Look, you can't drink, but you can vote. And that's exactly what we expect in this range here. But we don't need age is less than 21, because it's going to check the highest value first. And then as long as that's true, we don't care if it's under 21. We only care if you're 18 or above. 21 or above, or 18 or above. It'll automatically catch 18, 19, and 20 will automatically fall into here. So we can go ahead and comment out that line, and we'll uncomment this line here, which basically just removes this section right here. And if we run it, we'll get the same result. Because this catches, are you 18, 19, or 20 years old? If that is false, then it'll come down here asking, are you younger than 18? Which technically this could actually be the else statement, and you wouldn't even need this one here. So let's go ahead and do that, just to make it cleaner, and we can say else, because if you're 17 or younger, all these will be false. That means you must be younger than 18 years old. Otherwise, this one catches everybody from 21 up to infinity. This one here catches everybody 18, 19, or 20. And then the else would be anybody who's 17 or below. So we can run it. You can't drink or vote. Let's go ahead and pick a 17, because we're checking the edge cases here. Okay, you can't drink or vote. Yep, okay, so the final one ran. So this is cleaned up and more simple, much more readable than this bit of code right here. Okay, so think about your indentations when you're creating it. think about what variable are you comparing to. If we're only looking at a single variable and we're comparing it to different sets of values, well then use an if, else statement block. Don't do if. It's not a good way to do things. If you want to do like a single if to check, hey, if name equals Tony Stark, welcome home, Mr. Stark. Otherwise, it's just going to skip that code. Or if admin equals true, then grant admin permissions. Otherwise, there just must be a regular user, and you don't want to grant that. So you just can run a single if you wanted to. But if you're checking more than one thing, typically you want to run an if, else statement. So think about it and apply some logic to it and see which method makes the most sense. If you're checking a single value, then you want to use the full set of blocks. Okay, now let's look a little bit. Right. This week we're doing rock, paper, scissors. We're making a game for it. And in order to succeed, you need to accomplish a couple steps. So whenever you're building a program, you need to think about what steps need to be done to go from nothing to a completed program. Normally in a class like this, you'd be looking at some pseudocode. Pseudocode is just basically like, if you look at the back of a pizza box, a frozen pizza box, the directions on the back are essentially pseudocode. They're just a list of directions. Do this, then this, then this, and finally do this. And you're just writing in plain English. So essentially, this is like pseudocode right here. Get a user value. Get a random computer value. Convert one of the values to get a matching like values. I even give an example. A 1 should be equal to an R. And then compare user value to computer value. And then you want to print out the results. All right. So this is essentially what pseudocode is here. It's a step-by-step set of directions of what you want to do in your code. So let's look at the first one. Let's see. We all know how to get a user value. User value equals input an RP or an S. I've seen some different ways of people doing it. Some people are spelling out rock, paper, scissors. Some people are just saying RP or S. RPS is kind of ambiguous. Some other things you might want to do, so like user value equals input, enter rock, P, paper. There we go. Autocomplete, finish it, and that way the person knows input an R, input a P, or input an S, to keep it simple. Or some people have even done R for rock, P for paper, or S for scissors. You can do that as well. That way they know to input R, P, or an S. Some other options. So when we look at strings and we look at slicing strings, what we can do is we can actually tell it to look at the first character. So that way if they input an S, it'll take the S. If they input the word scissors, it'll only look at the first character. If they only input an S, it'll look at the first character, and the first character just happens to be the only character. But if they were to happen to have the entire word, you can tell it, hey, only look at the first letter. So we'll actually look at that one next week, because slicing is connected very tightly to looping. So today we'll glance at looping, but you want to be able to slice letters, and that's going to combine the two of them together. More strings. I know everybody loves strings by now. Okay, so the first thing we want to do is get a random integer. Okay, so get the user input. Okay, you can do it just like this right here, and make your request make sense. Right? If you just say R, P, or S, somebody might not know what R, P, or S stands for. Oh, in this case, I'd probably want to do a dot upper to make it all uppercase. So basically, dot upper just means anything on the left side here, capitalize it. That way, when you check it, you don't have to worry about, is it a lowercase r or is it a capital R? Is it a lowercase or an uppercase? In this case, it just forces everything to be upper. The other option is to do lower, and that forces everything to be lower. I think we looked at upper and lower last week, possibly 2 weeks ago. I think 2 weeks ago, because last week was mostly conditional statements. So you can force it to be upper or lower. That way, you only have to do one set of comparisons. Okay. Then we're going to get a random computer value. Okay. Well, from the random module, right? So from random module, we want to import the random integer function. And the random integer function is going to take in a range of values including the numbers that you put down. So it's inclusive. And we'll look at more inclusive and exclusive a little bit later when we're talking about loops. Okay, so we're going to get a random number. And see the comments? The comments should be with the bit of code that they belong to. I've seen some people that are putting all of their comments at the top of the page and then all of their code at the bottom of the page, and they're not associated with one another. That's not proper standards for commenting. So I know that these blocks of comments goes directly to this bit here. In this case, I'm actually explaining what is the purpose of my program, or of this section here. Well, I'm using the random module, and I'm getting a random integer using rand_int. Okay, and I know that this set of code belongs to this block right here. Okay, so get a random number. Rand is inclusive for both values, so it'll include 1, 2, and it will include 3. It's inclusive of the numbers inside. And then it's going to print a random value. So, okay, let's run it. Print. I got a random 1. It's going to print run again. 1. Print again. Oh, there's a 3. Run again. 1, 3. So if I get a 2 in here eventually. And there's the 2. Okay, 1. Looks like it's going to give me 1. Okay, let's go with the 2. Okay, next step, come up here, convert one of the values to a matching like value. So 1 equals R or something like that. Okay, well, we can convert. So last week we looked at match case. Let's go ahead and look at match case. Match case is good if you want to use a set of discrete checks. We always want to have our case underscore colon print invalid. Okay, we always want to have our catch-all case at the end here, so that was missing. Okay, so match random number. Okay, we set random number right here for the computer number. Okay, and if, or in the case that is a 1, print A. Okay, let's set 1 to A for apple, 2 to B for banana, and 3 to O for orange. That's right here in my comments. That way when the next programmer comes in, they're going, why is a 1 becoming an A? Oh, it's for an apple. Because remember, the code is for the next person, and the comments help everybody understand. Okay, so a 1, I'm going to go ahead and print it to the screen. Not required, but it's a good to let somebody know what it is. And it is a value of A. New value equals A. If it's a 2, it's going to assign new value to B. If it's a 3, it's going to assign new value to O. And one thing we could do is we could actually pre-declare new value. We can say new value, colon, and this is going to be a string value, because it is a character. Okay, and I'm typecasting, or I'm typecasting, I think they call it hinting, or I'm type hinting of what new value is supposed to be. So therefore, if I were to put in a integer, let's say I would put in a 1 again, it should pop up an error. Okay, if you're in like Python or something, it'll pop up an error. Let's take a quick error. Copy here. Let me open up Python. Oh, there's a Monty Hall Python. Yeah, if you ever want to look at a nice random value, simulate Monty Python. If you ever want to look at a nice, we'll look at this one at the end. This is actually a fun one. Simulate Monty Python. If you ever want to look at a nice, we'll look at this one. Okay. It's actually a fun one. Control V and see match random number. So an IDE like this is really good. Because it lets us see some of the errors codes and stuff really easy that you won't see if you're using Google Colab. Okay, there we go. So from random, getting random int, setting a random value 1 to 3. From random, getting random int. Setting a random value. That actually might be kind of small for you guys. Oh, I can't zoom in. And let me pull up on the screen. So let's get some PyCharm. There we go. We got some PyCharm here. Okay, let's see if I can get this zoomed in just a little bit. Okay, let's see if I can get this easier to see, because Google Colab is great, but Google Colab doesn't tell you errors and stuff like that. Google Colab is great, but Google Colab doesn't tell you errors and stuff like that. Google Colab is great, but Google Colab doesn't tell you errors and stuff like that. Google Colab is great, but Google Colab doesn't tell you errors. Google Colab is great. Okay. Go with that. PyCharm. PyCharm. I can't adjust the PyCharm size. Sorry, guys. Okay, the funs of dealing with it. So, all right. Hopefully it's big enough and everybody can read it. We're taking it in here. So I'm typecasting. I'm telling it, hey, make new value into a string. And then if I come down here to new value, it's saying redeclare. It's expecting a string. So if I put A here, it's expecting a string. So if I put A here, it's expecting A, and therefore it is expecting a string. If I were to do int, if I were to do now, it's saying, why are you trying to put a string value in there? Expected int got string instead. Why are you trying to put a string value in there? If we do string instead. Why are you trying to put a string value? The errors go away, and then if I come down here and I put a 1, it's going to underline that and say, hey, we expected a string, we got an int instead. Those are the kind of things you will not see in Google Colab, but you will see. Those are the kind of things you will not see in PyCharm. All right. So that's a little side case. That's type hinting. So that's a little side. Thought I covered that last week, but if not, you saw a little bit of it here. You could do int, float, string, and it kind of gives you warnings if you're going against that. It's not going to stop it from working, but it'll give you a little bit of a warning. Okay. It's not going to stop it. Go back to. There we go. Google Colab. Okay. So sorry about that little tangent there. Okay. So we'll typecast it. We'll say it's a string, and. We'll typecast it. We'll say it's an error. No. Yeah, see, it's not going to give us an error here in Google Colab, but it will inside one of the IDEs like PyCharm. Okay, so we got our 1 becomes an A, 2 becomes a B, 3 becomes an O for orange, and then if for some reason it's not a 1, 2, or 3, it'll just print out invalid and not assign it to anything. Okay, so let's see, if 2, if we run it, 2 becomes a B, it prints B, and if we were to print the value, let's go ahead and do that, print the value, print new value, we should also get AB again. Should be B. There we go. You can always just check the value, whatever value is inside that variable by doing something like that. Okay, let's go up. There we go. Compare user value to computer value. Okay, so we want to see what the user's inputted. So if the user inputted an A, okay, then and the new value equal to B, then we can print out, hey, you win. Okay, if the user inputted an A but the computer got an O, you lose. And this is an if, elif, and an else. So there's only 3 cases it could possibly be. So if it's an A to a B, you win. If it's an A to an O, you lose. The only remaining option it could be is a you tie. Therefore, you do not need to check user input equals A and new value equals A because it's going to be a tie anyways. So check one, check the other. If it's not one of those two, it has to be the else statement. Right? There's no need to check the A equals A. You just put you tie, and it's going to get one of those 3 answers right there. That's one thing to remember is that once you've gone through everything, if everything else is false, what is the only option remaining, right? That's like some of you, if you have siblings, let's say you have a brother and a sister. You know, your parents might come home and say, hey, to your sister, you didn't take out the trash. Why not? And your sister might go, oh no, it was Jason's turn. All right. So your parents go to Jason, and they say, hey Jason, why didn't you take out the trash? And Jason will go, it's not my turn. Well, your sister said it wasn't their turn. Jason said it wasn't their turn. So whose turn must it be? Well, it must be your turn, right? So it's as simple as that. If, elif, whatever's left becomes the else. That's the easy way to blame your siblings, right? All right. So let's look at a sample program. Let's make a game called high-low. Okay. So in this case, we want to generate a number 1 to 10, and the user has to guess the number, and the program responds high, low, or you guessed right. Guess 4. You get 4 guesses. Well, in this case, you actually only get 1 guess because there's no loop. But later on, when we add a loop, we'll add 4 guesses to it. So what we want to do is we want to get a random integer, right, from our rand int get a random integer class from the random module. If you don't do this, then you actually have to fully name the function. So you could say import random. If you just want to import the entire random library or module, then if you have the word rand int, then you have to go random dot rand int. Every time you want to use random int, you have to add the random dot each time. So the simple way is if you only want to use, so from random there's random choice, there's random int, there's random itself. You can also get Gaussian distributions, things like that. So there's a lot of different functions or classes inside the random module. So instead of importing the entire module, we just want to import one specific function, the random or rand int function. Okay, and that there we don't have to use the word random anymore. Okay, so we'll get a value 1 to 10, random, and we'll assign a secret number. Okay, and then we're going to take a guess a number between 1 and 10. Okay, and then we're going to convert it to an integer and put it inside guess. And then we're going to look at our if, elif, and else statements. All right, now if the number is between 1 and 10, you guessed outside the range, please choose a number between 1 and 10. If guess is less than the secret number, you're too low. If guess is greater than the secret number, you're too high. If neither of these or three are true, well then that means they must have guessed the right number. Okay, so if we want to run that, okay, guess between 1 and 10. Say they would guess a 3. Okay, guess between 1 and 10. Hey, I guessed correct. That is totally random. Okay, let's guess 3 again. Okay, in this case we're too low. And if you notice, I have to hit play every single time I want to play. Okay, let's try a -1. He guesses out of range. I have to hit play again. So it doesn't track how many times I played. It just plays one time. And while a guessing game is fun, just playing it one time and having to hit restart every single time, well, that kind of makes it boring because you only get one guess. You're either going to guess it right, which my first guess of 3 and I won, that was totally random, right? I have a what percent chance of getting that because we're looking at 1 to 10 inclusive, so 0 is not included in there. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have a 10% chance of guessing the right number. Maybe I should have played the lottery. Okay. It would also be annoying to have to write the same code. So if you want to play 4 times, you could say, number of guesses, and then you could basically copy paste this code 4 times, and you'll get your 4 guesses. Well, that seems like kind of a waste and inefficient, right? We're always trying to find efficiencies in our code. So we only want to write the code once. If you ever find yourself writing the same line more than once, then you probably either need a function, which we'll learn about, I believe, module 6, or you need to make a loop to go through the same code. That way it runs the same snippet of code without having to rewrite the code. So either a loop or a function if you find yourself writing the same code more than once in your program. Okay, and this is where loops come in. Okay, so we're going to finish with conditionals. Does anybody have any questions on conditionals? Pause for a sec, take a drink. Anybody have any questions on conditionals? Or want an example of something? Anybody have any questions on conditionals? Or want an example of something? Anybody have any questions on conditionals? Or want an example? Everybody's happy. All right, not a problem. Well, loops are one of my favorite things because when you combine loops with conditionals, you can actually start writing real program code. All right, so you can actually start making games that will play indefinitely and let you go on adventures or guess multiple numbers. That's when you can apply loops and conditionals together. That game or programming actually becomes programming. Now, functions are a good thing. Also, functions are kind of like a loop. We'll look a lot more of those in module 6. But for now, this is pretty exciting that we're getting into looping here. And this will also start helping out for those who have want to get a head start on next week's assignments. All right, so let's get loopy. All right, 23 cells in this one. Let's get loopy. It's going to be a big one. All right, so loops are a fundamental tool in program. It lets us execute the same block of code over and over without having to rewrite it over and over and over. Let's say we want to say, hello, I love programming 10 times. Well, you can make 10 print statements that all say the exact same thing, 10 print statements, or you could just make a loop that says, hey, do this item 10 times in a row. All right, so we can write them multiple times, and they help us automate repetitive tasks. It helps keep our code cleaner, readable, and efficient. Efficiency is what it's all about. And in Python, specifically, there are two types of loops. You have a while loop, and you have a for loop. There are two types of loops. If you look at other languages, some other languages have a do while loop, but Python never added that one. So it's just a while loop and a for loop. So looking at the while loops will keep looping indefinitely while they are true. So you can see here, while the basic syntax. So while true, whatever condition is true, you can say while play game equals true. You can say while true itself, or you could say while x is less than 10, keep looping. All right, so whatever the condition is, it just has to evaluate to true or false, just like when we did the if statements. The if statements and conditional statements always evaluate to a true or false. If this is true, execute this. If it's false, go to the next part, right? Same thing with conditions. While true or false. While true, it's going to keep looping, and while false, it will break out of the loop and then go to the next set of code. Okay? This code here won't run just because it's the condition, but this is the basic syntax of how it's supposed to look. So let's say we want to loop with this. Let's say we want to have counters. All right. So we have. Let's say we want to have counters. All right. Oh, it fixed part of the code up top. So let me hit pass. Oh, there we go. Clear. This just tells it this. There we go. Belongs in here. Without this in here, it's like, hey, I'm missing something inside this loop, which affects the next block. All right. So loops with counters. So number of loops. We want our variables to be kind of self-explanatory of what we're doing here. So we want to loop 5 times. So while number of loops is greater than 0, this will evaluate this. Okay. So right now, loops is 5. 5 right now is greater than 0. That is true. If it is true, it's going to go inside the loop. It's going to print loop. If it is true, it's going to go inside. This is a formatted string, so it's going to print number of loops. In this case, number of loops is 5. So it's going to print. Then after it prints that, we're going to do the compact. So it's minus equals. Remember, minus equals is the same as number of loops equals number of loops minus number 1. That is the same thing as this right here. These are the minus the variable naming there. Okay, there we go. Number of loops equals number of loops minus 1. There we go. Is the same thing as the compact format there. We learned about that a couple weeks ago, right? So let's stick with compact because it's more readable. Every language in programming that I know of, I guess I can't say every language, but every language that I know of all have that compact syntax. Okay, so number of loops minus equals 1. So first run, 5 is greater than 0, true. Loop 5 is greater than 0, true. Subtract 1. Number of loops now equals 4. 4 is greater than 0. Number of loops now is going to print loop 4 is greater than 0. Subtract 1. Number of loops equals 3. 3 is greater than 0. Loop 3. Subtract 1. Loops equals 2. 2 is greater than 0. You can see where this is going, right? Loop 2. Number of loops minus 1 is 1. 1 is greater than 0. Loop 1. Subtract 1, 0. 0 is not greater than 0. That becomes false. It's going to exit out of the loop. You can tell whatever's inside the loop because the indentation. So it's going to exit out of the loop, and it's going to say loop is done. Its print name is outside of the loop because it's not indented with it. So when we run it, it should say 5, 4, 3, 2, 1. So when we run it, it should say then loop is done. 3, 2, 1, right? Let's see, and it will not say 0 because it won't run that last time through, that last comparison. And it will not say 0. 5, 4, 3, 2, 1, loop is done. And we walk through the loop, or loop by loop, seeing what is happening to the number value of loops, right? Or loop by loop, seeing what is happening, and printing out the value of loop each time it runs. Subtract 1, the loop again by comparing each time. Subtract 1, all right, the loop is done. We can also count from 1 to 5 using a while loop. So let's say I equals 1, while I is less than or equal to 5, print I. See, so I is a variable, right? So we can print I, and then we're going to add 1 to I. So here, we are subtracting 1. We're going to add 1 to I. Here, we're going to add 1. And in this case, I, J, and K are common iterators. Iterator means something that you can count 1, 2, 3, 4, 5, or 2, 4, 6, you know, 4 by 3s, you know, 3, 6, 9, 12, something like that. You're iterating through a sequence of numbers. So I, J, and K are very common just to be the variable all by itself. Often we say, oh, make sure your variables mean something constructed or, you know, beneficial, like number of loops. But if you're using I, J, or K, typically they're all by themselves because they're common iterators. Hence why we start with I, because I is iterative. Okay? So I is equal to 1. Okay, all right. So while 1 is less than or equal to 5, so that's true. It's going to print 1. Add to it. So that's true. It's going to so on and so forth. So 2 is less than or equal to 5. True. Print 2. So 2 is going to print it. If we run it, it'll go 1, 2, 3, 4, 5, right? Because as long as 5 is less than or equal to, so when 5 equals 5, less than or equal to, so when 5 equals 5, okay, no, I didn't. Okay, so while 5 is equal to 5, it'll still print out. So we get 1 through 5. Okay. Now, one thing you got to be careful for with loops is a thing called infinite loops. Okay, an infinite loop means where you set a variable, it results in a true evaluation. So while something equals true, and then while it's running the loop, it never gets to the point where the loop where the condition will equal false. If it never equals false, it'll just keep looping and looping and looping forever, for infinity. And therefore we call those infinite loops. So the way to break out of an infinite loop is to set a value to equal false, or to use the keyword break. You can see that right here. Okay, the infinite loop is a loop that never exits, or gets a false value, right? Which is why it didn't exit. Okay, so you can have either set a value or comparison to actually equal false, or use the break. So here's an example, an infinite loop example. I will never equal greater than 5. Okay, I equals 1. While I is less than or equal to 5, that is true, print I. All right, where are we ever changing the value of I? We're not. So when I hit play, it's just going to go and go. So when I hit play, it will never end. All right, that is called an infinite loop. Scroll up here because it's never going to stop. That is called. Hit the stop icon here. If you're running like in Python or something, if you're running something in Python, see it's saying, hey, it stopped on this value here. Because the user stopped it because it was going through an infinite loop. All right? Because the user stopped it because it was going through an infinite loop. Scroll back up. That is too much. There we go. Okay. And if you're in Google Colab, what you can do is you can just go ahead and clear selected outputs. And if you're in Google Colab, go back to nothing. Just go ahead and clear. But it's telling you, hey, something's not right here. Okay? And that's because we have an infinite loop. Hey, something's not right here. Okay? And that's because we have an infinite loop. Some things to think about the loop with syntax. Remember, you have your condition here. So this needs to evaluate true or false. You have your semicolon or your colon here, right? You always have your colon, just like the if statements, if conditionals. You have your colon, and then you have your indentation. Anything inside the indentation will break or will be part of that while loop. Okay. So here's another example, except we forgot to set play game to false, right? So play game equals true. While play game equals true, right? So we got our assignment operator, and then we have our comparison operator, the equal sign for comparing. We're going to print game is running. However, I have commented out play game equals false. So it should be an infinite loop. just saying game is running over and over and over. Okay, go ahead and hit stop on that. It'll take a second stop. Over and over and over. Okay, go ahead and hit stop on that. It'll take a second stop. We'll clear out that selected outputs. Okay, and what we need to do is we need to add something to actually say you are false. So while play game equals true, well that it does equal true. While play game equals true, print game running. Then we're just going to go ahead and set game equals false right away. I'm echoing the background. Then we're just going to go ahead and set game equals false right away. I'm echoing the background. Then we're just going to go ahead and set game equals false right away. I wonder why it's echoing. Turn that down. Thanks for letting me know. Okay, if it's still echoing, let me know. I turned down a couple knobs here. We'll see how it goes. It could be as much as I'm talking so loud. My voice is probably echoing off the wall and into the microphone. So let me know if it's still echoing. Test, test. Okay, there we go. Turn down the okay, good to go. And maybe I'll talk a little bit less loud too. I don't need to be yelling in the mic, right? Okay. And I turned down the gain as well. All right, so if we set play game equals false, it's going to run, it'll stop the first time it loops. So if we hit play, so I'm going to loop one time, right? So in this case, we have our initial comparison true, and we on purpose, test, test. Okay, you have to let me know on that one. No, you're not derailing the lecture. It's always important to make sure people can hear, because if there's nobody listening to the lecture, I would never know, and then I'll post it, and, well, you have echo for the entire video, and a lot of people do like to watch it later. Okay, so it's only going to run one time because we purposely checked the condition, and then on purpose we made sure we set to make sure there was a change of the condition to false. All right, another way to so while play game equals true, we know play game equals true, so we could actually take away equals true here, and it's just going to check what is inside this variable. And because it's a Boolean, it'll be either true or false. So if I hit play, it'll still check true or false, and it actually said game is running. If game equaled false, and we hit play, nothing should happen, right? No output, because this Boolean value is false. So it's going to evaluate. In fact, when we mouse over it, it says, look, it's false. Therefore, the while loop will never execute. So you can do play game equals true, but that's actually saying, you know, while true equals true. That's kind of repetitive. We only need a final evaluation. So while play game, go. The other way you could do that, instead of saying play game, you could actually just say while true. And then you could say print game running. Oh, all right. Okay. So you could say while true, print game running, and then you can actually use a break. So in this case here, we're evaluating, and it's always going to be true. There's no way to change this to false. So what you want to do is when a condition has been met, so maybe somebody's playing the game and you ask, hey, do you want to continue playing your game? Or you're running a program that is maybe web scraping data from stock markets, right? When you're done scraping the web, you might want to say, so while true, scrape the web. Once it's done scraping the web, once it's checked every little stock market price that you wanted to check, hit break. Once you hit break, it automatically jumps out. So we hit it, and it's only going to run one time in this case. So in here, we could have an internal loop saying scrape, 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 scrape for scraping the internet, or get information from an API or something like that. You know, run some code, run your game, and then once you're no longer wanting to play, hit break, and it'll quit. Okay, so if you have an infinite loop, make sure you set the condition somewhere to a false value, or hit break. Some people don't like to put true here, because if you forget to put break somewhere in there, it'll never stop running, and it has the potential to be an infinite loop. Now in this case here, it's pretty easy to see, because hey, this is our main loop for whatever this chunk of code is here, so it's pretty easy to know that we need a break. But sometimes when you have large amounts of code and you have loops inside of loops, which are inside other loops, you may forget to make a break on one of those inner loops, and you might not catch that it's an infinite loop when you're testing your code, unless you test every single case of every single value that you expect a user to do to see if there's a loop or not. So some people don't like to use true. I personally do like to use it when it's something really simple. But in general, I will actually set a value like play game equals true, and then I can use the set it to false later on, like when the person says they don't want to play anymore. So that's personal preference. There is no right or wrong answer on what to do it. So whatever works for you, be consistent. All right. So if you like using true, make sure you use your breaks. If you like to use an actual variable that is set to true, make sure you set it to false. Just be consistent in your code. If you keep switching back and forth, and when another programmer is looking at it, they might be like, dude, what is this guy doing? Or what is this girl doing, you know? So be consistent. There is no right or wrong answer. It's all about technique. Okay, using loops with conditional statements. So we just finished looking at all last week, and just a little bit at the beginning of this stream here, conditional statements, where you can combine the two of them together. And that's what I was saying, you know, when loops and ifs start coming together, I get really excited because you can actually make working games when you combine them together. So let's look about combining these together just a little bit. So sometimes, or in some of the assignments, we've asked people to input a number, right? Or input an R, P, or an S for rock, paper, scissors, right? Well, what you can do is you can validate that they're inputting a correct value. And until they input a correct value, just keep looping. Once they do the correct value, then you can continue on with the rest of the code, right? So in this case, we're going to say, while true, right? Get a user input, enter your favorite number. And then we're going to say, take that user input and we're going to check. This is a nice little function to know. Is it a digit? So if they put in a special character or an alpha character like an A, B, C, D, or a special character like a block or one of those dollar signs or something crazy, those are not digits. And it'll say, else, invalid input, please enter a number. And because we're inside a while loop, it's immediately going to go back up. It's going to say true, get another number. It's going to check if it's a number. If it is a number, it's going to go ahead and change it to an integer, right? So it could be a float or an integer. And if it's a valid is digit, it can change any digit into an integer. It'll just chop off the decimal value if it's a float value, right? And then the most important thing, we have our break statement here. So let's run it, see what it does. Okay, so let's enter your favorite number. Let's go with a 0, right? Because 0 throughout history wasn't always a number. You know, 0 didn't exist. Counting actually started with 1. So I don't know how people used to figure out that you didn't have anything anymore when the number 0 wasn't an actual number. If somebody wants to look that one up, when did 0 actually become a number? Might have been around the Roman Empire time, maybe the Greeks. But anyways, okay, so 0. You entered 0, it counted as a digit. Let's run again. Let's try an exclamation or an @ sign. @ sign, invalid input, and look, it re-prompted me for a number. Let's go with a crazy. All right, because this is crazy. All right, enter, invalid input. Got to be a number. Okay, let's go with a float value. Okay, 5 or 3.14. Why? Oh, because it takes it as a string. It thinks that is a period. Ooh. So okay, that string, it did not think that was a digit. Let's try a 9. There we go. Okay. So in this case, it actually only took an integer. There are other options. So I could say, is it a digit? Check if it's an integer. Islam mathematicians invented 0. That could very well be true. That could very well be true. I've heard that. So I couldn't remember exactly who. I just don't know when. All right. So after a digit, we could say elif, and we could try and change it into a float value. If it can change into a float value, then we can go ahead and convert it into an integer, right? Otherwise, it'll run the else and invalid thing. So we could actually run an elif to check for float values also. In this case, it's only letting us input an integer. Short little example here, right? So that should finish up our while loops. And remember, this is a loop that you could put inside other loops. Okay, there we go. First recorded 0 appeared in Mesopotamia around 3 BC. So I wonder what they did the thousands of years before that. And the Mayans invented it after 4 AD. 0 reached Western Europe in the 12th century. Oh, that took a long time to get in the 12th century. So it makes you wonder, what did you do after somebody bought out all your food? Did you say, I have not one food? That is crazy. Yeah, I always knew numbers didn't exist forever, or the number 0 was not a value in the past. That is just absolutely crazy. All right. Imagine being the first person to invent the value of 0, and other people are like, oh, you're so stupid. That's not a number, right? Because people had to have fought back against them. But anyways, getting back on topic. All right, so we looked at conditionals. We looked at while loops. We even looked at while loops with conditionals in it. Let's look at the second time of loop, the for loops. All right. A for loop in Python is used to iterate over a sequence. Okay, so while loops kept looping while something was true or false. For loops are going iterating over a sequence. We talked about iterating earlier, where we go 1, 2, 3, 4, 5. That's why we had the I, and we're doing a sequence of numbers. So it could be we'll learn about lists, I think next week or 2 weeks from now. Strings, like the word Leeward Community College, that string is a string. You can actually iterate over each letter of that string, or range of numbers. We'll look at range first. All right, and the syntax for that is for, we have a variable that we want to look at in a sequence. So we're going to look at a sequence, and we're going to loop through each time, and each time it loops through, it's going to assign a value to that variable that we can grab. You actually don't have to have a variable in there every time. You could say for something in a sequence, and you could actually do this, for underscore in sequence. I'll just say pass here because I don't want to, come on, cut that out. All right. And that clears out a lot of the errors. So if you use this underscore, then you're not actually using a value from here, but it's maybe you want to run something like 10 times, but you don't care about the value of the loop. You just want to do it 10 times. So maybe we'll actually ad hoc, we'll add an example of that. But sometimes you'll see this underscore. That just means we don't care what the value is. Just like when we do case underscore equal or a colon, when we do match case, we don't care what the value is. We just have to put a symbol there. And so in Python, the underscore symbol just means we don't care. All right, what's that song? We're not gonna take it, right? No, I guess that didn't really work out. Man, I'm showing my age. All right, so you can either have a variable, or you can just put, if you don't care about the variable, you can just put an underscore. Okay, for the basic loop, if we're using a range loop, right, because we said we can use a list, we can use a string, we can use a range of numbers. For the range, it actually has multiple options there. You just need one value at a minimum, which would be your stop value, all right? But you could also do a start value and a stop value, or you could do a start, stop, step value, all right? So in this case, if I just have a single number in there, that's my stop value. So we said for variable in sequence, right? Print, in this case, we're going to print the variable, okay? So range is going to go 0, 1, 2, 3, 4. It's not going to print 5. And the reason being, because 5, or will it print 5? Usually it doesn't include it. So I think that one's supposed to be exclusive. So it should do 1 through 4. Yep. So print 5 values. 0, 1, 2, 3, 4. The start is inclusive. So whatever value, if you put a value of start, it will include that number. But whatever the stop value is, it will stop before it hits that value, right? So it's going to check, is the range equal to 5? Quit and leave my loop, all right? So it's exclusive on the stop value. And then step just means like if you put a 2, it's going to do every other number. If you put a 3, it's going to do every third number. If you put a 4, it's going to do every fourth number, and so on. All right? But minimum, you have to have at least one number inside the range, and that is the stop number. All right? So let's iterate with a start and a stop value. So a first and a second value there. So when here, we didn't signify what the start value is. If you don't say what the start value is, it'll always start at 0. That magic number 0, all right? However, if you indicate what you want your start value to be, it will start at that number. Now, in this case, we're saying stop at 5. Remember, 5 is exclusive, so it's not going to include 5 when it prints it out. So the first time it runs, it's going to go print, or it's going to say for I in range. Range is going to say 1. So for the first time, 1. 1 is less than 5. Print 1. It's going to change. Now the next number, it's going to iterate to the next number. That's what for loops do. They iterate. It's going to say 2 For 2, 2 is less than 5. Print 2. 3, 3 is less than 5. Print 3. 4 is less than 5. Print. 5 is not less than 5. That's why it kicks out of the loop. And usually, like, remember I said, if you don't put the start value, it's going to start at 0. It gave us 5 values. That's also another reason why it does that, because counting starts at 0 when you're programming. So if we say range 5, we want 5 values. It's going to do that. If you want to make it easier to read, you could even say I plus 1, but I still is 0, 1, 2, 3, 4. So if we hit print, it'll add 1 value to it. So we do get our 1 to 5, but we had to artificially add 1 to that number. So that's always something to think about, is remember, it always starts at 0. Okay, in this case here, print 1 to 5. Let's go ahead and run it. And in this case, we're not starting at 0, we're starting at 1. So if we run it, it goes 1, 2, 3, 4, because once it gets to that last check, 5 is not less than 5. It's going to skip out of the loop. Okay, you can, as mentioned, you can also iterate over a string. So a string could be any number of words. It could be Leeward Community College. It could be the word Python. So in this case, we're saying for letter in Python, print that letter. So P is a letter. Y is a letter. It's going to iterate. The first letter is actually index 0, index 1, index 2, index 3, number 4, and number 5. Okay, so print, and it'll print through every letter in that string. Okay, so that's just an example of how you can go through a string. All right, and each letter, it'll print out 1 letter at a time. You can't have it do more than 1 letter at a time. But in this, if you notice, we're not doing a range. We're only doing a string. You can also do things like lists. Okay, but let's look at the start, stop, and the step iteration. So you might see this in an assignment next week. So hint, hint, take a look at this, right? For you, especially for those people that are watching it, the recording, hint, hint, look at this. All right, so you can designate the start, stop, and step when you're iterating through the sequence. So in this case, we want to get every other number starting with number 1. So it's going to start with 1 up to 10, but not including 10, because remember, it's exclusive, but it's going to do every other number, every second number. So it's going to go 1, 3, 5, 7, 9. 9 isn't 10, and the next number would be 11. 11 is not less than 10, so therefore it'll quit. So let's run it. And we'll see, look, we got the odd numbers. Every other odd number, starting with 1. But let's say we want to start with 2. All right, if we want to start with 2, we're going to do every other number. It'll go 2, 4, 6, 8, 10, right? Is that right? 2, 4, 6, 8, 10? Any opinions out there on the internet? And if it's not, why not? If it is right, okay, then we'll run it and we'll see what we got. You're probably betting it's not, though, because I'm asking, right? All right, well, we'll go ahead and run it. So it's not going to include the 10 because on the last 2, it's going to go 2, 4, 6, 8. 10 is not less than. Remember, it's excluded, so therefore we'll not include it here. If you really wanted to look at the number 10, you would literally have to add or iterate up to 11, right? And then it'll include the 10 into that list of numbers. All right, we'll go ahead and leave it at 0. That way, if somebody opens up the Google Colab, remember in the comment or the information section that you can expand just above the comments of the video, you'll find the link to this Google Colab, so you can check it out any point in time that you want. All right, so we just did, first one we did every odd number because we went by 2s. Now we're doing it every even number because we're going by 2s, starting with an even number. All right, so let's add loops to our guessing game. All right, so let's make this live. Let's go back up to our guessing game. I guess the people that see this video later, the code's already going to be done, but that's just the way it is. All right, there we go, our high-low game. Let's copy this block. Okay, you guess the number. Let's go down to where the loops are, and we're going to do this. So before, we could only play the game 1 time. We want to make it so we can play it multiple times. I know Herv is like, oh my goodness, this is so basic. But this is what actually makes it fun, right? Being able to add loops and conditionals together, okay? So let's make a guessing game with loops. So we still need our random number. We don't need import random, so we'll take this comment out. We need to go ahead and get our predefined secret number from the start, right? 1 through 10. And then we're going to get an input from the user. Okay. Now we want to get the input from the user each time. So that means we probably want to start our while loop while true, right? We could do that. And while it's going true, we probably want to do all of this indented. All right. So a proper indentation, if you hit tab once in Google Colab, it adds 2 spaces, but proper indentation in Python is considered 4 spaces or 1 tab. So in this case, 4 spaces. So that's why I tabbed twice. It just looks better for proper alignment. You can see it's even 4 letters here. So that's how the alignment's supposed to work. Okay, so we're saying while true. If we say that, then, okay, so if the number isn't in the range, guess out of the range, please choose again, right? If it's too low, we want to choose again. If it's too high, we want to choose again. However, if we choose it correctly, we probably don't want to choose again. So this would be a good spot for our break, right? We won the game. There's no reason to choose again. So if we hit play, this will let us play an infinite number of times. So we can try 1, too low. And look, it prompts us for another one. Okay, 2. Oh, congratulations. It was number 3. I remember the first one I did it way up top when it was only a single iteration. 3 was the magic number also. So I'm guessing the random number seemed to like 3 a lot. But look, we were able to guess 3 times in a row in a single loop just by adding while true. And all of this code is indented, right? Another loop you could ask, you could say, do you want to play again? At the end, instead of doing the break here, you could say, do you want to play again? If they say yes, then don't do anything. It'll just automatically go back to the top. If they say no, add a break. And it'll exit out of the program, right? So that's another, you could have a loop inside a loop. So yeah, let's do that. So while, or do, brain fart here, print input, nope. We'll go ahead and add it to a value here. Let's say play again. I know there's shorter ways to do it, but I like to spell it out, and then I like to go. Well, you can see the cheat code. Ay. Silly AI. Okay, so we'll let the AI finish the code for me, okay? I don't understand how it knows what you want sometimes, okay? So do you want to play again? Yes or no? It'll put the input into play again. If play again, dot lower. Remember, you can also do the dot lower here. I actually like doing it here myself. Instead of here. So play again is Y, then it'll give a new secret number, and then it will go back to the top here because while still equals true. But if it gets any other value than Y, so you could say R, S, T, N, any other value, then it's going to go ahead and break, and that's going to break you out of the entire first loop. All right? If we hit play again, okay, we'll guess 5, too low. Okay, so we'll guess 7, too high. So the number must be 6, right? Congratulations, you guess again. Do you want to play again? If I say yes, boom, it's going to play again. We'll go with 5. And too low. Let's go with 7. Congratulations, you guessed it. Do I want to play again? No. And it quit. We just added play again code, super easy with conditionals, and we can keep looping over and over and over with a single loop. And that's why I love loops and conditionals, because it lets you make entire games that are repeatable and playable, right? So, some key things to look here, okay? All the code that is indented is what's going to play. So what you could do is you could say outside of the loop, we could say print thank you for playing. And let's go ahead and say random number 1 to 2. Okay, now this code is not indented, all right, with any of the code that's inside the while statement. So this will only execute after the while loop is done, right? Let's hit play. The number has to be between 1 and 2, right? We'll try 1, too low, so it must be a 2. Congratulations, you want to play again? If I say no, actually if I say yes, it's just going to play again, right? Try 2, too low, try 1. I know I said random int 1 or 2. All right, we'll try 5. That's kind of weird. Too high, 4, 3. That is weird that picked a 3. All right. Sometimes it doesn't always refresh. I'm figuring that's probably what it was. In this case, we'll say no. And now it says, thank you for playing. Now, if you're doing like in Python, or if you're doing this in a text editor or maybe a console, if you say print thank you for playing, then it will actually just quit out of the console and nothing will happen. So if we want to try it, let's give it a quick try. I know I have console set up somewhere. So let's hop over to PyCharm, paste. Let me turn PyCharm on so you guys can all see it. All right, so we just pasted our code here, right? Thank you for playing is right here. All right, so if I want to execute in a console, command prompt, CMD. There we go. Okay, everybody can see that command prompt there. Okay, I'm going to go ahead and come over to PyCharm. I'm going to copy code test. Let me go ahead and run it once. Okay, that just updated the location here. Copy. So if I'm in command prompt, I type py, and then I paste location, it's going to play the game. Guess a number between 1 and 10. We'll try 2. Too high. We'll try 1. Congratulations, you guessed the correct number. If I say no, it's supposed to print, do you want to play again? Now I feel dumb. So usually what it does to me is it just closes the console window. So now I feel kind of stupid. In this case, it did not close the console window. Okay, if we did here, 2, 1, no, thank you for playing. All right. Normally what you want to do is you want to have it as an input, not as a print. And you'd say print, thank you for playing again. And then I would actually do an input, press any key to continue. And then you would do a ... or you just say press any key, ... and that actually wait for the person to press and enter. Normally it closes the command prompt window. So I'm actually shocked it did not. I feel a little silly, but it really does close the command prompt window almost every single time. So if you do an input, press any key, then we want to copy that, put this in our PyCharm at the very end, right? Okay, there we go. Okay, so if we come to the command prompt, which I have right there, nope. We'll paste it from here. All right, going a little off script here. I don't know why the command prompt didn't close last time, but we'll go with it, right? All right, 110. Congratulations, you guessed again. If I say no, thank you for playing. And see, it says press any key to continue. This is normally what you want. Okay, and then I can push any key, and usually it'll quit out of the command prompt. Okay, so sometimes what it'll do is it'll pop open a command prompt window, and then it closes it out after it's done. All right, I wonder if there's a, you know what, this is actually a new version of PyCharm. This is the PyCharm Pro, which is actually free for students, just so you guys know. So if you want to download the PyCharm Pro, it's free. You just have to use your student email, and you get a free license for 1 year on Python Pro. When I played under regular Python, it actually closed out the windows on me. So I think that's the difference here. I've only had the Python Pro for a couple weeks here. Okay, let's get out of that. Okay, back to the Google. I know you guys are all laughing at me. The second time you ran the game, it chose random number 110. Who's using the command line anymore? Not this guy, right? But, you know, it's an option. I think Herb still uses the command line. All right. So thank you for playing. Often you do want to include this in there. Press any key to continue. That way they can exit out, and then it'll close the window. All right. But let's say we want to take this a little bit farther, okay, between 1 and 2. Second time we ran the game, it shows a random number 1 to 10. So right now I have it set 1 to 2. I could change that to be 2 to be more accurate, but that's because I want to be able to guess more quickly. Let's do the first one. We haven't checked all the edge cases. Edge cases means you look at each one and you check. You know, so what if somebody inputs a 0? What happens if you input a 0? Your guess is out of range. So therefore we know. Okay, let's check an 11, which it should because it's only looking between 1 and 2. Okay, your guess is out of range, and it keeps looping over and over and over, asking us for a valid, number. Okay, let's guess a 3. Oh, 3 is too high. Let's guess a 2. Yay, I was correct with the 2. And no. Okay, thank you for playing. Press any key. Okay, I press any key. Which is funny. Back in the day, people used to say, at the end of your code, you say press any key. People would actually look on their keyboard for a key that said any key. Just like people say press enter, press escape. People would look for any key on the keyboard, and they'd get really frustrated when they couldn't find it, and they would actually call the help desk. Not saying that I used to be help desk back when I was a young Marine, and people would actually call us to say, hey, oh my gosh. Sometimes I thought they were trolling us, but it's true. They actually thought there was a key called any key. So go figure. But that press any key goes way back to the 80s. When I was a little kid, my parents had a lot of programs and stuff, and that was very common because everything was command prompt. That at the end of every program, you always pushed press any key. So just saying. All right. You could. Oh yeah, and the second one, and you're right, because I started that with the beginning of the program. I said anytime you have duplicate code, you can break that code out either into a loop or a function. However, Masticator, they haven't learned functions yet. Functions are coming, I think, in 3 weeks or 4 weeks from now. So the only things I can do is conditionals and loops. And loops technically don't even come till next week, so this is like an introduction to loops for them. So yes, a function would be the perfect spot to put that, but they don't know loops yet. But there are some students that actually do know some pretty advanced code, so they have included that loop functions. Even on week 1, they had functions and loops and lists and dictionaries in their week 1 code. So I'm like, this person already knows Python. But for a lot of students, they haven't learned it yet, so they can't do the functions yet. But you're right. Anytime you have duplicate code, put it someplace else. You could also put secret any number. No, that would have to be the right spot. In a function, and if you can't use a function at the beginning of the code, and if you're going to play again, you got to reset it, right? Okay. If you want to make a game that has colored and graphical health bars, but it's in a console, then you got to be a little creative and think, how did they do it back in 1980? All right. So let's unhide this. Okay, so we want a health bar that looks like this, where it says hero health. It has a vertical bar. It has 10 health blocks. Each of these is a block. And then it has another vertical bar. And we want it to always be this width. All right, so we learned a couple weeks ago how to multiply characters, right? So if you have a character, you can multiply it multiple times. In fact, let's go ahead and add a piece of code. Let's say I want to print, and in that print, I want to say, let's multiply 5 times. I can't believe I just put an X for times. The character here. And we actually did this week 1 assignments. Remember, or week 2 where you had to do knowledge is power, and you had to do the pound signs like 22 times or whatever. So we actually did this. So it'll print the asterisk 5 times. Well, that's essentially what it is here. So I'm saying, okay, I have 10 health. Well, then I want 10 bars, right? The time it becomes a little weird and you got to be creative, it's actually not weird. It's actually very common sense. But it's going to take a little bit of thinking, is how do you subtract 1 from health and then add some to the blank spaces? So this is what we want. And as the hero takes damage, we want to subtract a health bar and we want to replace it with an underscore, right? And then once the bar reaches 0, we want to print out, you have died. All right? So this is what we want. How do we get there? All right? We could, if we did not have loops, if we do not have loops, then it gets very painful. All right, so we can set our colors. I want green, red, yellow, and then I want reset. Okay, so if the health bar is like a lot of health, maybe the first like 10, 9, 8, maybe even 7, I want it to be green. If they only have a medium amount of health, so like maybe like 4, 5, or 6, then I want it to be yellow. And if they have less than like, so if they have 0, 1, 2, or 1, 2, or 3 health, then I want it to be red. All right, so I'll go ahead and set green, red, and yellow. I guess that doesn't have to be green 1, but we're green 1. And then reset just to set it back to normal. All right, so hero health equals 10. And you can see I'm type hinting because I'm doing the colon. So if I assign like a variable, like a string to it, to hero health, it's going to give me a warning saying, hey, we're expecting an int here, right? So type hinting, it's a good technique to do. Hero max health is 10. And we need both these values. The max health is actually the most important one because that's what lets you do your comparisons to find out what is the remaining health. And then to start off our hero, we could say remaining health int equals 0. And if you're making a game, you could actually say, what is the hero's name? As an input, and the person could type in the hero's name, and then you could put that above the health bar and make it all pretty, right? Okay. If we did not have loops, we could print the hero's health. I want hero health, just like in the example, right? Hero health with a colon. I want a vertical bar, and at the end, I want a vertical bar. I want green because they have a lot of health, right? And then I want to multiply the hero health, which is currently 10, right? If I mouse over it, it says literal 10, times this bar, block here, right? Because that's what I want to use for that. And then the remaining health is equal to, well, in this case, it's equal to 10, right? And we just want blank spaces for that. And then I want to go ahead and reset the colors. That way this bar at the end here won't be green. Okay. Let's take a look at what this will actually look like first, and then we'll go back and explain it. Where did I mess up? Green 1. Oh. Did I miss? Oh, because I didn't hit play on this block. Okay. And now I can hit the play on this block here. Forgot to run the previous block, right? Okay. So if we run it, this is what it looks like. And I want to go from 10 health, 9, 8, 7, 6, 5, 4, 3, 2, 1, and once it's 0, you have died. If we don't have loops, you have to do that for every single one. So hero's health equals 9. Remaining health equals the max health minus the hero's health, right? So 10 minus 9, it gives us 1 remaining health. And then we can print it out again. Hero's health, we want to make it green, multiply 9, right? Because now it should be equal to 9, even though it's saying 0. Okay, so hero's health is 9 times the block. Reset it, and then I want remaining health, which will be 1 in this case, times the underscore. Same thing. Hero's health equals 8. So I want 8 of the boxes. Remaining health is 8, 10 minus 8 gives me 2. And that's how it's going to go each iteration until I got 1. Once it equals 0, if hero's health is less than or equal to 0, print in red, you have died. And then go ahead and reset your color. You always want to reset. All right, and that gives us this look here. That's great, but that is way too much typing. Oh, wow, we're at an hour and 20 minutes. Okay, we're going to wrap this up kind of quick. Looking at, I know you guys are all riveted, and you can't wait to see how this works. Herv, if you want to challenge, see if you can turn this into a loop, decrementing by 1. And the next week, we'll actually look at the code I have created. And using a loop. Am I crazy or does it smell like Module 4 hint? Yes. This is related to Module 4, but not Hero Health. But if you look at Module 4, and nobody's attempted Module 4 yet, nah, or maybe the final project of Module 4, and I'm betting it's because I gave some tough challenges in Module 4. So yes, this directly relates to Module 4, which is why I'm super excited about it, but not Hero Health necessarily. It's about drawing pyramids and changing shapes and alignments, and it's pretty crazy. But good catch. So Herv, challenge for you, or anybody else that wants to give it a try. Try and put this into a loop that subtracts 1 health each time. So therefore, you only have 1 loop, and as long as the health is greater than 0, keep looping and subtracting 1 from the health bar. And redraw this here in 1 loop. So therefore, you should only have one block of code like this just one time, right? See if you guys can get this, and then next week, which it's actually right here, it's right down here, I'm hinting at it. I'm going to have to hide it from the Google Colab, aren't I? That way you guys don't see the solution. And then I'll move it to next week's, all right? So we're going to call it quits here because it's been an hour and 20 minutes. Thank you, everybody, for who's joined in. For those that haven't, please watch. I hope you guys watch the video later, which you won't see this message if you don't watch it later anyways. But this will help you with this week's assignments and start hinting at next module's assignments. If there's any questions, please ask them. Otherwise, I'm going to go ahead and end here and remove the solution and move it over to week 6. Give a couple seconds here for any questions. If you have questions, I can hit code here and I can demonstrate some code. I'm looking to the left here, so I guess... do you guys not see that one? Command prompt. That's there. Okay, you guys don't see my face today. Oh, I'm sure you guys are so sad. Okay. Check your email about Module 4. I will. Okay. Thanks, everybody. And you all have a good week. All right? End stream. Where are you? There you are. All right. You guys take it easy.